Hello, I'm Luis Bejarano and I'm going to explain how to find the maximum and the minimum of an equation using a method called the second derivative method. Okay, this method is very simple. We are gonna use it with a not so simple equation so you can see the really useful part of it, and it's very useful, very short also. Okay, step 1, you need your problem, your function in terms of any variable. Then you have to differentiate that function. This is step 1. Once you have this, you equal that derivative to 0, and this should give you one or two answers. Step 3, these answers you get in step 2, you plug them as a replacement of the variables on step 3. And what do I mean? Here on step 2, you would have to get something like x, or your variable, equals a number or a constant at least, and here you change all of those variables by this constant you get previously. You actually don't have to get the exact answer of step 3 as long as you know it is more than 0 or less than 0, positive or negative. If it is less than 0, it is maximum, and if it's more than 0, it is minimum. So for example, if you have a graph something like this, okay, the answers you're gonna get with one of them, this derivative over here, is gonna be less than 0. That is going to be approximately this part, and the other one this part. Okay, let's continue. For the sake of this problem, we're gonna use this equation. Very simple. What does this mean? There's a force expressed on this rope with mu in the weight, mu, and everything in here is going to be explained later, but very simple. The problem asks you to find the minimum force you have to do with certain weight, with certain coefficient of friction at a certain angle, so you make the less force possible. Okay, so let's explain this equation. You have mu, the coefficient of friction. This is the friction made by two materials that are moving one against the other, or this is static, this moving, or both moving, etc., etc. It's a very complicated number because it depends on so many variables. If it is right, heat, yada yada yada. But you can find a lot of tables on internet that have this information for certain materials at certain specific points at those variables, and the weight, normal weight, expressed in kilograms, and what we care of, that is the angle. Why? Because the angle is our only variable. As you see, of this problem, mu is not gonna change, this is not gonna change, but the angle is our variable. So if you have the weight and on the surface, it's not the same force you have to do if they are both, I don't know, lubricated ice. It has to be a very little tiny angle to make the least force, something like this, I don't know. But if it is, let's say, dry rock against another rock equally of rough, you have to do a lot more, a lower angle to make the smaller force. So what do we conclude? The higher the mu, the higher the angle. You have little mu, you have to have a big angle. So you have to, so you do the least force. If you have an mu on the sky, you have to have an almost or totally horizontal angle. Okay, we are starting with the process. This is step 1. Step 1, first derivative of the previous equation, and you can check that, but believe me, this is it. When you equal this to 0, or variable, it's equal to this. So what does this mean? The same I was telling you early. The angle depends on mu. So if you have a high mu, you are going to have less angle, and vice versa. This is what this means. Okay, let's go to step 3, because if you saw, this is step 1, this is step 2, and this is step 3. This little monster over here, so cute, and all of these thetas you see over here and there and everywhere, you are going to replace it for the tangent, the arc tangent of mu, depending on your specific problem. As you do that, well, you replace it and you know if it is a maximum or a minimum. This problem has only one answer, because we only care of one answer. We are only finding the minimum. So that's it. If we are trying to get the maximum and the minimum on here on step 2, between step 1 and step 2, we have to do an extra process so we can get 2 instead of 1 answer. Okay, that's it over here. So for the sake of this problem, what we are gonna do? Weight 10 kilos, mu 1.0, this is for dry iron against dry iron on a static situation. This means this has a velocity of 0, this has velocity more than 0. Okay, y mu equals 1. Well, because thanks, it's going to really simplify this equation. So this is the last step, step 4. You have your derivative and the arctangent of 1, that is or mu, is approximately 0.78 radians, and when you replace over here, I'm sorry, you get that the answer is more or less 7. This has a lot of decimals over here, and we don't really care about this. We only care that it's more than 0. So we know that when the angle is approximately 0.7, this is our angle, radians, you have a minimum. So this is it, that's all. Our problem, the same weight, the same surface, so 0.78, that's, well, very low, or something here maybe, 0.7, oh no, almost here, something like this. Yeah, it's a very high mu, and most of them are between 0 and 1. Very few, they are 1.2 or something like that. So if you see, it's a very high angle, a very low angle for a very high mu. And well, that's it. I hope you understand. Thank you very much.